Percent solutions are a lot more common in everyday life. If you think about going to the grocery store and buying lemon juice or vinegar, if you look on the container, it will tell you what percentage that solution is of the actual vinegar or lemon. If you buy rubbing alcohol, you're going to find 70 or 90% isopropyl alcohol, depending on which solution. If you buy saline solution, it's percents. So the two circles where percent solutions are most common are in commercial ventures, anything you buy from grocery stores and things like that, but also in medical circles, saline solution and IV drug bags and stuff like that are sold by percents. Okay, so percents are always part over whole, and in a percent solution, it's going to be the part is going to be the solute, and the whole will be the solution. So if you're doing a solid solute, then we figured out by the mass of solute per mass of solution. So, for instance, a salt solution would be the grams of salt in the grams of the whole solution. Now you have to remember that the solution includes both the solute and the solvent. So when you figure out the mass of the denominator, you have to figure out, okay, is it the whole solution or is it the solute plus the solvent? Now, if you have a liquid solute like alcohol, rubbing alcohol, then it's volume of solute over the volume of the whole solution. Okay, so percents are easy if you just remember they're part over whole. In the case of a percent solution, oops, I'm getting ahead of myself. The part will be the solute and the whole will be the whole solution. So if we ask the question, what is the percent by mass of a solute in a solution made by dissolving 8.37 grams of salt in 600 grams of water? A lot of you would look at this and go quickly, oh, look, it's 8 grams of salt divided by 600 grams of solution. No, the 600 grams is the whole, it's just the solvent rather. So the whole solution would weigh 608 grams, okay, which would make it a 1.38% solution. Now I could also give you the percent of the solution and say what mass of solute would you need to make 150 grams of the solution. Okay, so percent is part over whole, the part is the solute, the whole is the solution. So you just set it up. Now some of you will forget that when you use the 15%, the working close-up percents are the decimal form. So you have to change the 15% to 0.15, and then you can make the mass of the solute X and the mass of the solution 150. Okay. Then solving for X, you cross multiply and you get 22.5 grams of solute. Now, if you were making this solution, a common mistake would be to take 15 grams of salt in 150 grams of water, which would give you the false amount because that would give you 165 grams of solution. So how would you find out how much solvent you need? Okay, and I'm getting ahead of myself again. So let's try another problem. If you have 20 grams of solute, how many grams of 13% solution can you make? How many grams of solvent? So you have 20 grams of solute. You want to make a 13% solution. So how would you make it? So again, you change the 13% to its decimal equivalent. You say 0.13 equals 220, which is the grams of solute, over X, which is the grams of solution. But we want to make this solution. We want to know how much work we can make if we only have 20 grams of solute. So to solve for X, first thing we have to do is get X in the numerator. So easiest way is to cross multiply and then divide. So you end up with X equals 20 divided by 0.3, which is 154 grams of solution. Now, if out of that 154 grams, 20 of it is solute. So how much solvent would that be? Now the math here is really complex. You have to take 154 minus 20, and you get 134 grams of solvent, 20 grams of solute to make 154 grams of 13% solution. Okay, so that's percent solution.